Uh, Good evening, everyone. I hope I am audible and the PPT is visible. So it's already 6. So I'm going to start the live discussion session on the topic soil water statics. This is the fifth problem solving session of this course, Geotechnical Engineering 1. So this particular topic, this session has approximately 20 questions, which comprises of multiple choice questions, MCQ, uh, true false statements, and a few numericals. So I'll first dictate the questions, and as and when the students join, I believe they can write down the questions. So I'll directly go to the PPT right now. Yes, I hope the PPT is visible. So yes, so this session has 20 questions. The topic is soil water statics. I hope the concept of this chapter uh, have been thorough with the students so that they can uh, grasp the questions and solve the numericals effortlessly. So I'll just start with dictating the questions one by one. Someone joined. So those of you who joined, please write down the questions now. I'll dictate them, and don't discuss or don't speak out or write the answer in the chat box. After I dictate all the questions, I'll give you some time, around 15 minutes approximately, to solve these questions. You need to stay in the meeting, and after the break, the time when you solve these questions, I'll start discussing the solutions and explain them simultaneously. Okay, so I'll start again. Good evening, everyone. This is the fifth live discussion session of the course Geotechnical Engineering 1. Uh, the topic of today's session is soil water statics. I'll start dictating the questions now. So the first question is, yes, coarse grained soils have relatively low hygroscopic moisture due to their coarse grained soils have relatively low hygroscopic moisture due to their. Your options are: first option, greater angle of internal friction; second option, limited specific surface; third option, low cohesion; and fourth option, none of these. Someone has joined right now. Yes, I have already started. This is the first question anyway. So please write down the questions first. Then I'll give you some time to solve these questions. After which I'll start discussing the solutions. So today's topic is soil water statics. And this is the fifth live discussion session of Geotechnical Engineering 1. So the first question, this is the first question, I'll repeat. Coarse grained soils have relatively low hygroscopic moisture due to the options are greater angle of internal friction, limited specific surface, low cohesion, or none of these. Greater angle of internal friction, limited specific surface, low cohesion, or none of these. Okay, I hope the question was clear. I'll go to the next question. Yes, almost reversible reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of. Your options are silica, illite, montmorillonite, or kaolinite. I repeat the question. Almost again, please write down this from the correct question. This is the second question. Who has joined? Dheeraj Raghuvanshi. Yes. Almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of. The options are silica, illite, montmorillonite, or kaolinite. Almost reversible swelling and shrinkage on re-wetting and re-drying can be observed in soil having high content of silica, illite, montmorillonite, or kaolinite. Okay. Next question. Yes. This property offers an explanation for the bulking of sand. This property offers an explanation for the bulking of sand. Your options are slaking, high friction angle, activity, or apparent cohesion. Someone has joined now. This is the third question. Yes, I repeat. This property offers an explanation for the bulking of sand. First option, slaking. Second option, high friction angle. Third option, activity. Last option, apparent cohesion. Which of this property is responsible for the bulking of sand? Slaking, high friction, activity, or apparent cohesion? Okay, I hope the question was clear. I'll go to the next question. Yes, this is a small numerical. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is. Your options are 6.05, 7.03, 6.62, 7.05, all in kilonewton per meter square. Just a moment, there is a problem with the internet connectivity. I'll try and rejoin the meeting first. Yes, am I audible? Hello? Yes, sorry for the inconvenience. There is a problem with the internet connectivity over here. So it is fluctuating basically. I just got disconnected. So I think you have seen this question, right? This one was the last question. I was,
What is gamma evolution?
huh? What
Gamma
is
W.
what is gamma W? Okay,
Yeah.
in this case, I think you can take gamma W as 9.81. You can take as 9.81. Take 9.81 over here. Okay.
Okay.
Okay, so yes, this was the question. The maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade. The options are 6.05, 7.03, 6.62, and 7.05, all in kilonewton per meter square. I'll just check the connectivity. Okay, yes, it's fine. Okay, so I'll go to the next question now. Yes. The pressure transmitted from particles through their points of contact through soil mass is called. The pressure transmitted from particles through their points of contact through soil mass is called. Your options are neutral pressure, total pressure, effective pressure, or saturated pressure. Excuse me. I repeat the question. The pressure transmitted from particles through their points of contact through soil mass is called. First option neutral pressure, second option total pressure, third option is effective pressure, and the last option is saturated pressure. Okay. Okay, I hope the question was clear. I'll go to the next question. Yes. Entry of air into the void spaces of clays during drying below shrinkage limit followed by immersion in water causes. First option swelling, second option slaking, third option shrinking, last option expansion. I repeat the question. Entry of air into the void spaces of clays during drying below shrinkage limit followed by immersion in water causes. The options are swelling, slaking, shrinking, or expansion. Okay. Next question. Yes. When the water level in a lake or tank rises, the effective stresses in the soil below are. Options are increased, decreased, depends on particle size, or remains constant. I repeat the question. When the water level in a lake or tank rises, the effective stresses in the soil below are increased, decreased, depends on the particle size, or remains constant. Okay, next question. Yes. The effect of capillary saturation will cause the effective stress to, the options are increase, decrease, can be both, or remain constant. This scenario is considering the total stress remaining constant. Okay, then the effective stress will increase or decrease. I repeat the question. The effect of capillary saturation will cause the effective stress to, options are increase, decrease, can be both, or remain constant. Okay. Next question. Yes. Structural water can be removed by oven drying at 55 to 65 degrees centigrade. Is this statement true or false? Just a small hint, a similar kind of question has already been discussed in one of the previous problem solving sessions. I repeat the statement. Structural water can be removed by oven drying at 55 to 65 degree centigrade. Is this statement true or false? Okay. Next question. Yes. In the capillary saturated zone, the pore pressure is. In the capillary saturated zone, the pore pressure is. Your options are tensile, compressive, can be both, or zero. I repeat, in the capillary saturated zone, the pore pressure is. The options are tensile, compressive, can be both, or zero. Okay. Next question. Yes, another numerical. Water table was found 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. If the saturated unit weight is 18 kilonewton per meter cube, the effective stress at the water table level in kilonewton per meter cube is, sorry, it will be meter square. I believe it is stress, so it will be meter. Okay, so there was a glitch in my OBS recorder, I believe. I'll just repeat the question. Yeah, water table was found 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. If the saturated unit weight is 18 kilonewton per meter cube, the effective stress at the water table level in kilonewton per meter square. I just write over here, just complete the statement, is. The options are 8, 9, 18, or 0. Okay, I believe you can solve it. Next question. This was the 11th question, by the way. Yes. Okay. Another true or false statement. Hygroscopic moisture can change due to gravity or capillary action only. Hygroscopic moisture can change due to gravity or capillary action only. Is the statement true or false? I repeat the question, the statement, brother. Hygroscopic moisture can change due to gravity or capillary action only. Is this statement true or false? Okay. Next question. Neutral pressure is, first option, always tensile. Second option, always compressive. Third option, compressive below the water table and tensile above it. Last option, compressive above water table and tensile below it.
Sir,
Yes.
you have mentioned it is a neutral pressure.
Yes.
Nowhere you have mentioned soil.
Yes, that is the thing. The sign convention you have to,
You have to
answer.
imagine or what?
Yes, you have to go with the solution. There are sign convention based on, whether it is above or below the water table, whether it is always positive or always negative. Okay, whether it is compression positive or compression negative. So that is the thing. This is the general question about the neutral pressure. So just,
Okay.
yeah. So the question was, neutral pressure is always tensile, always compressive below water table and tensile above it, or compressive above water table and tensile below it. Okay, next question. Yes. The effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level, saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per
Sir,
meter cube
screens.
is.
Sorry, screens.
Screen is okay, the screen has not changed.
Question you have to change.
Okay,
Question you have
okay.
not changed.
Question have changed, but it is not showing. Wait. This is the problem, Uh, PowerPoint, Google Meet, and then OBS recorder, something or the other. As I was telling you one day, something or the other might have a glitch. I believe now you can see the, question, the effective stress. Is the question visible now?
Yes, sir.
Okay, fine. Yeah. So the effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level, saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per meter cube is, the options are 154, 124, 194 or 144, all in kilonewton per meter square as mentioned in the question.
Gamma W tensor.
Oh, gamma W not given. Wait, I'll tell you. Gamma W. Yes, gamma W in this question also take it as 10. Okay. No, in the last question I mentioned 9.81, right?
Sir.
Yes. In this question you take it as 10. Okay.
Yeah.
Okay. I repeat the question once. The effective stress in kilonewton per meter square at a depth of 10 meter below the ground level when water table is 3 meter below the ground level, saturated density is 20 kilonewton per meter cube and bulk density is 18 kilonewton per meter cube is, the options are 154, 124, 194 or 144, all the options in kilonewton per meter square. Find out the effective stress at 10-meter depth. Okay. Okay. Next question. Yes. The question has changed here. In the capillary fringe, the effective stress is. In the capillary fringe, the effective stress is. First option, less than the total stress. Second option, greater than the total stress. Third option, equal to the total stress. Last option, can't be said. I repeat the question. In the capillary fringe, the effective stress is, first option, less than the total stress. Second option, greater than the total stress. Third option, equal to the total stress. Last option, can't be said. Okay. So next question. Now I have to check the OBS also and the Google Meet also. Yes, if both have the slides changing, then only I can start dictating the questions. Anyway, it's all right. Okay, so the last question. Yes, capillary fringe. Yes, softening of soil due to melting of ice is commonly known as. Softening of soil due to melting of ice is commonly known as. Here I am talking about the capillary fringe, that zone of soil. Okay. Softening of soil due to melting of ice, specifically in the capillary fringe. What is it called? The options are frost heave, bulking, slaking, or frost boil. I repeat, softening of soil due to melting of ice is commonly known as, I'm talking about the capillary fringe, where it mainly occurs, it can be mainly seen generally. The options are frost heave, bulking, slaking, or frost boil. Okay. So next question. Okay. A river 5 meter deep consists of a sand bed with saturated unit weight of 20 kilonewton per meter cube. Here gamma W has been given, it is 9.81 kilonewton per meter cube. The effective vertical stress in kilonewton per meter square at 5 meter from the top of sand bed. Options are 41, 60, 50 or 51. I repeat the question. A river 5 meter deep consists of a sand bed with saturated unit weight of 20 kilonewton per meter cube. Here gamma W is 9.81 kilonewton per meter cube. The effective vertical stress in kilonewton per meter square at 5 meter from the top of sand bed is 41, 60, 50 or 51, all in kilonewton per meter square. If you get the answer in a decimal, you can just round it off to the nearest whole number. Okay. Okay. So now next question. Yes, another numerical depth. Yes. The depth of water in a swimming pool is 6 meter. The total and effective stresses in kilonewton per meter square at a depth of 3 meter below the top surface of water is. So the options will have the first one as the total stress and the second one as effective stress. The options are 10 and 30, 10 being the total, 30 being the effective. Option B, 20 and 20. Yes, you raised a hand. ARB.
Gamma W 10, sir, I think.
Gamma W. Gamma W, yes, 10, 10. 10.
Okay, sir.
Yeah. Gamma W is 10. So the second option is 20 and 20. Third option is 0 and 30. Last option is 30 and 0. 30 being the total and 0 being the effective stress. I repeat, the depth of water in a swimming pool is 6 meter. The total and effective stresses in kilonewton per meter square at a depth of 3 meter below the top surface of water is. Options are 10 and 30, 20 and 20, 0 and 30 or 30 and 0. Okay. Okay. Next question. Another numerical. Let's change over here. Yeah. A 2-meter thick sand layer of density 1.7 ton per meter cube overlies a 4-meter thick saturated clay of density 2 ton per meter cube. If the water table is at the interface, the effective pressure in ton per meter square at the center of the clay layer is. Here consider the rho W, that is the density of water, as 1 ton per meter cube. Density of water 1 ton per meter cube. Okay. The options are 7.4, 5.4, 2.0 or 3.4. Of course, if you get the answer in decimal places, more than one decimal places, you can round it off to one decimal place. I repeat, a 2-meter thick sand layer of density 1.7 ton per meter cube overlies a 4-meter thick saturated clay of density 2 ton per meter cube. If the water table is at the interface, that is between the sand and clay layer, the effective pressure in ton per meter square at the center of the clay layer. Effective pressure. Options are 7.4, 5.4, 2.0 or 3.4. Okay. Okay. Next question. The last question. Yes, I think you can see it. The ground conditions in the site are shown below. Please draw the diagram. Simple one. This is the ground level containing the water table. Here the water unit weight we will take as 10. Specific gravity of soil solids is 2.7. The soil is sand. The moisture content, water content is 20%. And P is a point located at a depth of 5 meter from the ground surface. Okay, the ground level. Using these conditions as given in the figure, you have to determine the saturated unit weight of sand in kilonewton per meter cube first, and secondly the total stress, pore water pressure and effective stress in kilonewton per meter. I think it will be meter square, isn't it? It will be meter square, yes, per meter square at the point P. At the point P. So first of all, draw the diagram, or you can take a screenshot also, whatever you are comfortable with, and then find out the saturated unit weight of sand, and then find out the total stress, the pore pressure and effective stress at the point P located at 5 meter below the ground level. Okay, moisture content 20%, soil is sand having specific gravity of soil solids 2.7, and the unit weight of water is 10 kilonewton per meter cube. Okay, so I think the questions are clear. So it is 54 now. How much time do you need? I guess 10 minutes, 15 minutes, or will be okay. Okay, I'll start at 7:10 or 7:05, whatever you are comfortable with, because there are not so many numericals and the numericals are, I think, simple. You are raising a thumbs up For which time? 7:05 or 7:10? Okay, I'll start at 7:10.
Okay, sir. Fine.
Okay, okay, fine.
Sir, a small query, sir.
Yes, yes, please.
If you have access,
Yes.
uh, in the assignment number 5, week 5,
Okay.
the question number related with the capillarity, fifth question, please check if there is any mistake. I don't want any answer because deadline is there still. If there is
Assi-
any mistake, you can tell me.
Assignment 5.
Yes, sir. Assignment
Uh,
5, week 5, fifth question.
okay, but I don't know that assignment questions are made by, I think, professor, right? Some professor. So, me checking
Mhm.
the
Okay.
the authenticity or the mistake
Okay,
in
sir.
that
Understood.
question, I don't think I'll be comfortable with. Okay.
Okay, sir. Fine, fine, fine.
Yeah. Hello, am I audible?
Yes, sir.
Yeah. I believe you have completed solving the questions. I'll start with the solutions now. Yes, any
Okay.
question? Yeah, okay, fine. The first question was, yes, coarse grained soils have relatively low hygroscopic moisture due to their, any answer? What is the answer?
I think option B, sir.
Option
Low
B.
specific surface area.
Yes, yes, very good. Low specific surface because specific surface means surface area per unit mass. They have higher particle size. So if the surface, if per unit mass surface area is less, then it will be difficult for the water, not difficult, less amount of water will be absorbed on the surface. Okay. So because of their limited specific surface, the coarse grained soils, they have comparatively low hygroscopic moisture content. And when I say comparatively or relatively, it obviously comparing with the fine grained soils which have higher value or higher magnitude of specific surface. Okay. So yes, specific surface, low specific or limited specific surface is the correct answer. Good. Next question. Almost reversible swelling and shrinkage on rewetting and redrying can be observed in soils having high content of. What is the answer? This is also easy, I believe.
C, sir. Mount Morlite.
Yes, see, Mont Morillonite because of their interlayer swelling. They have high magnitude of interlayer swelling. So, on wetting, it swells. On redrying again, it shrinks. Okay. So, reversible swelling and shrinkage on rewetting and redrying. This drying and wetting cycle can be observed in soil having high content of montmorillonite. For example, black cotton soil, right? In black cotton soil, there is high swelling and shrinkage observed because it has a high percentage of this clay mineral, montmorillonite. So yes, C, montmorillonite is the correct answer. Is the correct answer. Good. Okay. Now next question.
Sir,
Yes. Hello.
here is reversible.
Hello.
Here the question says reversible.
Yes, reversible. Yes, almost reversible.
But yeah, how many cycles it is reversible, sir? Actually, when you go for drying, wetting, like that. Normally in practically we have two seasons in our country. One is
Yes.
summer and winter. But in laboratory, we can make as much as possible reversible cycles in woven.
Yes, that's why it is said, I think almost reversible, almost reversible. And I haven't practically done this or practically have, insights into this phenomenon. Like I haven't seen this drying and wetting cycle on soils having montmorillonite. What I know is only theoretical. But I think that what you're talking about, that will also depend on other factors like which other minerals are present along with montmorillonite. So exact answer like how many cycles, okay, that I will not be able to answer at this moment, but I think that will be dependent on other factors too apart from the percentage of montmorillonite. And since this question I have taken from a sample question book and standard textbook combined, there also I haven't found any possible answers to your question, direct answer to your question, but it was written almost reversible. Okay, almost reversible. So I guess it is not fully reversible, and at some point of time the swelling and shrinkage might become negligible, but right now I don't have any answer, proper answer to your question. I might have to look into it further. Okay.
Fine, sir.
Yeah. Okay, so the answer of this question is montmorillonite. Okay. Okay. Next question. This property offers an explanation for the bulking of sand. What is the answer?
Option D, apparent cohesion.
Yes, option D, apparent cohesion. What is that apparent cohesion? It is the interparticle, adhesive forces. When uh, moisture content increases, like this, if you have a graph, this is the bulking percentage, increment in the volume, this is the moisture content, it increases, this is the graph like this is the bulking of sand. Okay, and what happens is there is an interparticle attractive forces. Okay, interparticle attractive forces because of the capillary action of water, isn't it? Because of the capillary action of water, that interparticle attractive forces, it forms a honeycomb type of structure. Okay, now sand does not have cohesion, but those attractive forces, interparticle attractive forces, because of the capillary action of water, it creates a sense that it seems that it has cohesion. So that is actually not true cohesion, it's an apparent cohesion. That's why we use the term. And generally in case of sands, the moisture content at which it is found, it approximately ranges from 5 to 6 percentage. Okay, 5 to 6 percentage. So yes, the answer is correct. Apparent cohesion, it offers an explanation for the bulking of sand. Okay, up to a certain limit. Then again, upon the increment in moisture content, the what happens, the capillary action, the water in the capillary fringes, the meniscus, it gets destroyed, and then again there is a decrement in volume. Okay, so up till the capillary fringe is being built up, the water in the capillary fringe is filling up. Up till that point of time, the volume increases around 5 to 6%. The volume is maximum because of the capillary action of water, and there is an apparent cohesion between the particles. Okay, so the answer is D, apparent cohesion. Okay, next question. Yes, the maximum capillary tension for a tube of 0.05 mm diameter for water at 4 degrees centigrade is. What is the answer of this question? Have you solved this?
So,
Yes.
yes, sir. I think option A, as per me.
Yes. Very good, very good. Option A, option A. So there are actually two formulas. You can find the derivation in any standard textbook. One is for 4 degrees centigrade. What am I writing? 4 degrees centigrade. Another is for 20 degrees centigrade. Okay. So for 4 degrees centigrade, first of all, there is a formula for HC max, maximum height of the capillary action. Okay, HC max. What is HC max? The formula for HC max for 4 degrees centigrade, it is 0.3084 divided by the diameter in centimeter, and this height also will be given in centimeter. And at 20 degrees centigrade, this formula becomes 0.2975 divided by D in centimeter. Again, this value HC max in centimeter. So given over here 4 degrees centigrade. So using this formula and using this diameter in centimeter, you find out the value of HC max first. The answer will be approximately, the value of HC max will be approximately 0.617, I think, isn't it? 0.617 in meters. In meters. Now the maximum value of capillary tension. So capillary tension, the maximum value of capillary tension will be how much? It will be HC max into gamma W. Gamma W I have told you to take as 9.81, isn't it? As 9.81. So the value will be approximately 6.05 kilo Newton per meter square. Okay, is it clear?
Yes, sir. I need some time to spend here, sir. Even the answer I told correct.
Okay, you're writing down.
Because
Yes.
because this example only I am facing problem with the assignment.
Okay,
Now I
so
want to clarification of
yes.
What is a effective size and effective diameter and relation? I
Effective
think,
size and effective diameter and their
yeah,
relation. Okay,
yes,
that
yes.
that will take some time. I think I have seen this example in actually we are not allowed to go through the assignment and the assignment question. We are not allowed to discuss the assignment problems.
Okay,
So
okay, okay.
I don't know
Same,
about
same.
yes, I don't know about whether this question you're asking me is it is there in the assignment or not. But I believe I have seen this in some standard textbooks. If not standard textbooks, I think you'll be having some gate
Yeah, this is
materials.
correct, sir. Yeah,
Yeah, this
this
is
what you have done is correct only.
yes, yes. But the your question, effective size,
Hmm.
effective diameter, these kind of examples, you will be
Hmm.
finding more and more numericals. The more you solve, the more the concept gets clear. In any gate examples, gate question bank, you can see and you can solve them from there. Okay.
Okay, sir.
Yeah. Okay, so here's the value. The answer is 6.05 kilonewton per meter square. This is the maximum value of capillary tension. Okay, next question. Very simple question. Pressure transmitted from particles to their points of contact through soil mass is called, what is it called?
Effective stress.
Yes, effective pressure, effective stress. Because it is a grain to grain transfer. Neutral pressure is the pore pressure. Total pressure is effective pressure plus pore pressure. And saturated pressure is, there is no term as saturated pressure, saturated unit weight. And that can be multiplied with the depth to find the, you know, weight or the pressure of the soil mass. So this is, the answer is effective pressure. Good. Okay. Next question. Just a minute. Yes. Entry of air into the void spaces of clays during drying below shrinkage limit, followed by immersion. What is it called?
Slaking, sir.
Yes, very good. Slaking. So what happens is when you dry below the shrinkage limit, okay, then the water from the pores, you know, they start oozing out or they start evaporating. Evaporating is the correct word, I believe. And the pores are then filled up with air. Okay, then when the pores are filled up with air and then you are just after drying, you immerse the soil sample in water. Because of that immersion, there is a sudden flow of water which creates high pressure and the release of the entrapped air, which causes disintegration of the structure of the soil sample, and that is called slaking of clay. Okay. Okay, good. Slaking is the correct answer. Next question. Yes. When water level in the lake or tank rises, the effective stress in the soil below R, what happens?
Option D remains constant.
Yes, obviously remains constant because effective stress means it is a grain to grain transfer of load of the soil particles. It will not change irrespective of the increase or decrease in the level of water above. Okay. Had I mentioned total stress, then would have been increased, right? But effective stress will remain constant. Okay, good. Next question. Yes. The effect of capillary saturation will cause the effective stress to, what will happen?
Increase.
Increase, right? Option A you're talking about.
Yes, sir.
Yeah, your voice is breaking. I think there's a problem with the connectivity. Okay, yes, increase. Effective stress will increase. Why? Because capillary saturation. I mean, there are more questions, similar questions with this concept. It will be clear next. But the capillary saturation, the pore pressure is negative. So we know total pressure equal to effective pressure plus pore pressure. Pore pressure is negative. For the same total pressure, the effective stress will be increasing. Okay, there is another question, similar question. Yes, structural water can be removed by oven drying at 55 to 65 degree centigrade. Is this statement true or false?
False.
Yes. So what is the temperature range we need for
Around
Above the
105 to 110 uh, डिग्री
one?
सेल्सियस 105 से 110 डिग्री सेल्सियस
Who is that? Dheeraj Raghuvanshi. Is that you? No, 105 से 110, 105 to 110 degree centigrade. Okay. This is the range we follow for oven drying of a soil sample. But is removing structural water our motive while we do that? When we oven dry a soil sample before any laboratory test or anything like that, is removing structural water our motive for doing that? Yes or no? When we oven dry soil sample between 105 to 110 degree centigrade, removing structural water, is that our motive?
no, no,
नो
sir. It
सर
is only free water we can remove.
Yes, the free water we can remove because structural water they are chemically bond, right, with the particles. So there was a question in any of the previous lecture, if you see, that I have mentioned that if we go beyond this temperature, more than 110, then there is a chance that the chemically bond water might get released. So it has to be more than 110 degrees centigrade. This is correct. This is the right range we follow while oven drying. And less than this, the one I have mentioned over here, it is nowhere near, the temperature which we need to follow to oven dry soil sample. Okay. So the yes, this statement is false. The answer is false. Structural water cannot be removed by oven drying at 55 to 65 degrees centigrade. The correct answer will be structural water can be removed by oven drying at a temperature of more than 110 degrees centigrade. Then there is a chance that the structural water can get removed. Okay. Okay. Next question. Yes. In the capillary saturated zone, the pore pressure is, what is it? Tensile, compressive, both, or zero? Yes,
Tensile.
tensile, right, tensile. I'll just draw the pressure diagram over here. This is not a cross, this is, I'm not yet finished drawing. Yes. So this is the water table, and above it, the soil is supposed, saturated with capillary action. So here it is, compression positive, compressive, acting downwards. It will be here negative, so it means it is tensile. Okay, this is tensile. Good. In the capillary saturated zone, the pore pressure is actually tensile. Next question. Just a moment. I'll just check. Yes. Okay. Next question. Water table was found 1 meter below the ground surface. Above the water table, the soil was saturated with capillary water. If the saturated unit weight is 18 kilonewton per meter cube, the effective stress at the water table level in kilonewton per meter square is. What is the answer you have got? What is the answer you have got?
0, sir.
0. This is the ground surface, right?
Yes, sir.
So above the water table, the soil is saturated with capillary water. There is capillary action. So during this capillary action, what happens? The rule we follow, that is total stress equal to effective stress, isn't it?
So, Yeah. Sorry, sir. I thought of it as a pore water.
Yes,
Mistake.
no, no, not pour water. It's okay.
Pore, yeah.
Yes, yes.
Both
So
are equal.
yes, so I think the depth is 1 given over here. Yes, 1 meter. The depth is 1
Op-
meter.
Option C, sir.
Option C, 18. Yes, it is
Yeah.
18 kilonewton per meter square.
Yeah. Sorry for that.
Yeah, yeah, no problem. The concept should be clear. Okay, it is just a practice session, so it is no big deal. The concept should be clear. The effective stress at the water table is at the water table level, because it is capillary reaction is involved over here. So what will it do? Will not, you know, what to say? Will not subtract this pore pressure. Rather, the total pressure is pore pressure because it is the capillary reaction. Okay. Next. Yes.
The
Someone has
effective stress at the ground level will be very interesting question, sir.
effective stress as the ground level, like here.
Ground level will be interesting.
Yes, interesting, but above this there is no soil, so it will be 0, I guess. Okay, and also I believe I might have made a misnomenclature about this. Don't write it like this, because sometimes you see, as in the next question I'll say, total stress equal to effective stress is not the correct nomenclature. Okay, it is just the effective stress, because there's another question where I will let you know that because of the capillary action, what is the relationship between total and effective stress, and both of them are definitely not equal. So just apologize for the misnomenclature over here. Not the total stress. This is the effective stress only. Okay, effective stress only, and because in this effective stress we consider this value of this effective stress, rather than subtracting the water, we take the water into consideration and we write it like gamma sat into z. Z equals to 1 over here. When we talk about total here, then we have to deal with the pore pressure, which is negative over here. Okay, so there is a relationship between total pressure and pore pressure, effective pressure, which we'll see. But in this scenario, don't mention total pressure. I have mentioned effective stress, and because it is a suction case, effective stress will include gamma sat and not gamma submerged, as in the general cases. Okay, I'll come to the relationship later because I've already given a question. Okay. Next question. Has it recorded? Yes. Hygroscopic moisture can change due to gravity or capillary action only. Is it true or false? Is it true or false? This is, I think, easy.
I think it's false, sir.
Yes, it is false. Why?
It is related with the surface action.
Yes, surface action, and it gets absorbed because of the charges involved, right? If this is a soil particle, okay, then there is moisture over here. This is adsorption, right? The moisture getting absorbed due to surface charges. Okay, and this is an inherent property. Specific surface might help in this scenario. This is an inherent property. Okay, there are some properties which might, there are some factors which might influence this, but those are not gravity or capillary action. It can be temperature. Okay, it can be the soil texture, it can be the mineralogy, or the humidity. Of course, the humidity, it will affect, but not gravity or capillary action. Okay, so this statement is false, that hygroscopic moisture can change due to gravity or capillary action. This statement is false. And SS, I mean, specifically I should write over here. SS means specific surface. Okay. Next question. Yes. Neutral pressure is. This is also easy because a similar question has been solved. What is the answer? This is water table.
Sir, this question I raised a small concern earlier.
Yes.
Neutral pressure in water is different, neutral pressure in soil is different. You have not mentioned anywhere about soil name.
Neutral pressure not in water, neutral pressure in soil, which is synonymous to the pore pressure. You know, in general scenario, pore pressure is also termed as neutral pressure. So when you talk about pore pressure, that is also another name for neutral pressure. That is nothing but if it is above the water table, okay, then there is capillary suction. If it
No, no,
happens,
sir. Neutral pressure.
yes, yes, yes. Continue.
Sir, my question is, for example, you take a swimming pool.
Yes.
So in swimming pool, the answer is different because you have only water. Then the neutral pressure comes as always compressive.
Okay. You are
Anywhere.
talking about other scenario when there is no soil or there is a different. No. Just
Yeah,
yeah,
that is what I want.
just think about the general, soil conditions. So see, my point in giving this question was like this. This statement was that this general soil condition. There is a soil and there is a water table. That is a given scenario. Okay.
That is what I am asking, sir. Soil word
Yeah.
is not there. If you mention, it will
Yeah.
be good
Okay.
actually.
So I need to write over here neutral pressure
In soil, if you write,
in
it is
soil,
clear. Yeah,
in
that
a
is.
given soil mass or in soil, right?
Yeah,
In
then
soil.
now it is clear.
Okay. So neutral pressure in soil. So now it is option. Which one?
Option, yeah.
Option C.
Compressive below the
Option.
water table, tensile
Yes.
above it.
Yes. Very good. Compressive below water table because it is positive. Compression positive. Tensile above it. Very good. Okay. So this is the answer. Next question. Yes. Have you solved this? What is the answer? So the scenario was
124, sir.
124. Yes, you're right. The scenario was something like this. So this is the water table at a depth of 3 meter. Okay, the soil is dry over here, and from 10, like this is 3, this will be 7. Okay, at this point, need to find out. So here, gamma dry. What is gamma? What is the bulk density? It is 18, isn't it? Here it is 20, but you have to find out the effective stress. So effective stress at the point, suppose this is x dash, x dash will be equal to the first layer. I'll take it as 18 into 3, right? There is no water over there, so total stress equal to effective stress plus here it is water, so 20 is the saturated density. So I have to take the submerged one, and I have told you, I think, that to take the gamma W as 10, right? So 20 gamma sat minus gamma W, this gives us the gamma submerged into the depth, that is 7. So here I have 54 plus 70, we get 124. Okay, the unit is kilonewton per meter square. So 124 is the answer. I hope it is clear. Okay, next question.
Yes, sir.
Yeah, next question. In the capillary fringe, the effective stress is, yes, this is what I'm talking about. The effective stress is, what is the answer? So I have told you for constant value of normal stress. Yes, please tell.
Option B, sir.
Greater than total stress. Very good. Greater than total stress. Yes, suppose here we have sigma. Here also we have sigma. Oh. Yeah, here also we have sigma. Okay. So we know sigma equals to this total stress equals to effective stress plus pore pressure. but here it is negative, here it is positive. Sorry, is equals to effective stress plus u, it will be here, it will be effective stress minus u. So for here in this scenario, effective stress will be equal to total stress plus u. So in this capillary fringe, this is the capillary fringe. Okay, this is the capillary fringe. Effective stress will be obviously more than the total stress. This is the correct answer. In the capillary fringe, effective stress is greater than the total stress. Okay, I hope it was clear. Okay, next question.
Yes, sir.
Yeah, next question. Okay, softening of soil due to melting of ice is commonly known as. What is the answer?
Frost boil.
Yes, frost boil. First, what happens when the the water freezes? There is frost heave. There is frost heave, and when the water melts, the consistency increases. Consistency means the ease of deformation. That is called frost boil, and I am definitely over here talking about that portion where there is capillary action, or the capillary fringe. Okay, capillary fringe. In there, when the ice melts, the phenomenon is called frost boil. What happens is the consistency increases, not consistency index, by the way. That ease of deformation. The soil can now be obviously easily deformed because the moisture content increases. Okay. So yes, the answer is softening of soil due to melting of ice is called frost boil. Next question. Yes, have you solved this? What is the answer? Yes, what is the answer? Looks like I've got disconnected again. I'm just Am I audible? Hello, am I audible?
Yes, sir.
Yes, the PPT is visible, right? Sorry, there was a problem
Yes, sir.
with the internet connectivity. Yeah. So, have you solved this? What is the answer you have got? Not writing the unit quickly.
Option D.
51, right? Good. 51. It is 20. Yes. So, I have asked to find out the effective effective stress at 5 meters on the top of the sand bed. So, this is 5 and this is 5. Okay. So, effective stress at z bar, z dash will be equal to how much? Submerged unit weight, 20 minus 9.81, 20 minus 9.81 into the depth, that is 5. The value will be approximately, I'll get 50.95, and rounding up will give us 51. Okay, easy question. Okay, now next question. Yes, depth of water in swimming pool is 6 meters. If total and effective stress, have you solved this? What is the answer?
And 0.
Yes, this is 6 meters. This is
Option
water.
D.
There is no soil. Gamma W I have told you to take as 10. Okay. So we have to find out at a depth of 3 meters. this is 3 meter. So up till here, the total pressure is equals to the pressure of the water. So sigma will be equal to gamma W into 3, that is 30. Okay, and there is no soil, so sigma equal to 0, 30 and 0. Clear? Next question. Yes, have you solved this? 2 meter thick sand layer of density 1.7 ton per meter cube. What lies a 4 meter thick saturated clay? Yes. Have you solved this question?
Yes, sir. 5.4.
5.4. Yes, I believe it is the correct answer. So the center of this layer, so this is 4, basically this is 2, this is the center of this layer. You have to find out. So this is the water table, and density of here, sand layer density is 1.7, and over here this is obviously rho sat density, saturated density, it is 2, and I have told you to take rho W equals to 1 ton per meter cube. So now this is the, suppose this is xx dash, so sigma, that is effective stress at x bar equal to the first layer, that is 1.7, that is dry, no water, so it will be total equal to effective plus the second layer till 2 meter, that is half of 4, that will be equal to gamma sat minus gamma W gives us gamma submerged into depth, that is 2. So here we have 3.4 plus 2, I believe it is 5.4 ton per meter square. Okay, so it is 5.4, second option. Good. Okay. Now the last question. So this is the ground condition that has been given. So have you found out the saturated unit weight of sand?
Yes, sir.
What is the answer?
21.038.
Yes, 21.03, 21.04, correct. So how do you find out gamma sat? You have properties of index properties. From there you can see the formula, that is G plus, where it is gamma
E
sat,
G plus
we
E.
don't write S because S is equals to 1, G plus E divided by 1 plus E into gamma W. So first of all we will find out E equal to WG by S, right? W means moisture content into G by S, S equals to 1. Okay, S equals to 1. So W, this moisture content 20%, G is 2.7. So it will be 0.54. Okay, 0.54 value of E. Put over here, G equal to how much? G equal to 2.7. Yes, E equal to 0.54, and gamma W, so we mentioned over here 10. So the answer will be approximately 21.04 in terms of kilonewton per meter cube. Very good. What is the total stress over here then at the point P?
105.2 kilonewton per square meter.
Yes. Gamma sat into 5. Gamma sat 21.04 into 5, 105.2 kilonewton per meter square. Okay, what will be the pore pressure? It will be
50 kp.
gamma W into 5, that is 50 kilonewton per meter square. Now what is the effective pressure? It will be total pressure minus U. What is the value? What is the answer?
55.2.
55.2 kilonewton per meter square. Okay, so I believe in this class you have got a brief idea about the type of numericals that you can solve, the basic, some of the basic concepts regarding the terminologies and other relationships. So thanks again for making this session uh, interactive. Again, like the last class, this session was also a very interactive session. So thank you for attending the class. We'll again meet on the coming Friday on the sixth problem solving session. Okay. Thank you. Have a good evening.